on our range today, and I have a Colt government model caliber 45 ACP with a 5-inch barrel. That's pretty standard. And I have a Kimber stainless target 1911 platform caliber 45 ACP with a 6-inch barrel. Now that's not an artifact of the camera. It's a long slide that has a barrel that's an inch longer than our government model. And today we're going to be comparing these two in terms of the velocity difference between the standard 5-inch and the long slide 6-inch barrel. Now this comes with a few caveats. One being that today's presentation is not a review of Kimber firearms. It's not even a review of this stainless target model. We're not going to compare these two firearms for accuracy in terms of would the inch longer barrel with this longer sighting plane make it any more accurate. We're not going to do that because these two firearms have different grips. The sights are very different, and so there'd be too many extraneous variables to make that a fair comparison. We're only going to compare and discuss the difference in velocity between the 5 and 6-inch barrel. Now to do that, it requires that I start with a demonstration. I've done this demonstration before, and so we're going to repeat at least part of it for today's presentation, so bear with me. Let's take a look. I've got the chronograph set up at 7 yards, and I have my Colt government model with its 5-inch barrel loaded with Remington green and white box 45 ACP 230 grain jacketed hollow point. Let's see what kind of velocities I get. .873. .486. 823, 812, 830, 811, 815. Now, obviously there was something wrong with the 486. I think there's something wrong with the 873 as well, so we're going to throw out both of those. But let's shoot a couple more shots. .807, and .815. Now, I'm going to try that with a different gun. Now I have my Rock Island Armory 1911 platform. Still has a 5-inch barrel. It's loaded with the same Remington green and white box 45 ACP 230 grain jacketed hollow point from the same lot of ammunition. I'm shooting the same chronograph at the same distance. Only a couple of minutes has gone by, so the angle of the sun hasn't changed. So we should get virtually identical velocity. .811. .506, obviously some kind of malfunction. .823, .521, .825, .813, .839, .831. Again, we'll throw out those that represent obvious malfunctions. But let's shoot a couple more shots. .834, .811, .800, and .820. Now let's go crunch those numbers. So what was the purpose of that demonstration? What I have demonstrated on a previous occasion was that if I have two firearms that are the exact same make and model, they're really identical, and I use ammunition that's identical, and I use them under identical conditions, as in same chronograph, shot from the same distance, only a couple of minutes passing between shooting the first string and the second string, so they're shot under identical conditions. What I got was identical velocity. But I've also found that if I have identical ammunition shot under identical conditions, but in two firearms that, even though they have the same barrel lengths, are not the same model of firearm, sometimes you get velocities that aren't the same. So today, shooting our Colt government model and our Rock Island Armory, even though they're both very similar firearms and they have the same barrel length, and shooting ammunition out of the same box under identical conditions as far as the chronograph and the time of day, are we going to get the same velocities? Well, with the Colt government model, I got a mean velocity of 816. With the Rock Island Armory, 820. 4 feet per second difference. That's well within the variation of one round to the next, not enough difference to make a difference. So what we're seeing is here today with this ammunition and this type of firearm, the idea of different firearms giving us different velocities doesn't seem to apply too much. And so what that tells us is that now that I have the same chronograph at the same distance, basically the same time of day, only a couple of minutes has gone by since I shot the last string, and that I'm using the same Remington green and white box 230 grain jacketed hollow point ammunition out of the same box, but now in my Kimber pistol, that really the main causative factor that will determine any differences in velocity should be just the barrel length. So let's see what kind of velocities I get with this. .843. .840. .830. .854. .866. .840. And again, let's shoot just a couple more shots. .847. .820. .838. .834. And .839. Now let's go crunch those numbers. Well, I crunched the numbers, and remember with the Colt government model, we got a mean velocity of 816. With the Kimber and an extra inch of barrel, we got a mean velocity of 841. That's 25 feet per second more. Now, a lot of times I'll stand here and tell you that an extra 25 feet per second isn't enough to matter. And if I were comparing two firearms where one had a velocity of 2,000 and the other had a velocity of 2,025, I'd be telling you that it wouldn't be enough to make any difference. However, when your velocities are down there pretty close to 800 feet per second, an extra 25 feet per second may be enough to make a difference. And that brings me to the two questions that I really wanted to ask today. The first one is, when you have a 1911 platform with a 5-inch barrel, which is really typical, loaded with 230 grain projectiles, and you compare that to a 1911 platform with a 6-inch barrel and the same 230 grain projectiles, will you get more velocity out of the longer barrel? And if so, how much more? Now that's question number one. And we've answered that. Yes, you will get more velocity. How much more? About 25 feet per second. Now the second question is a little more complex. The second question is that extra 25 feet per second of velocity enough to make a difference? And even more so, is it enough to make the difference? Now to answer that, the first thing we have to do is take a step back and ask the question, what do I mean when I say the difference? And to answer that, we have to do a demonstration. Let's take a look. What we have here is a demonstration medium known as the meat target. And for those who haven't seen it before, the meat target is leather couch skin followed by pork steak pectorals, pork ribs, a bag of oranges to simulate lung tissue, more pork ribs on the back, 4 layers of t-shirt on the front, 4 layers on the back, and the whole thing followed by the new and improved high-tech fleece bullet stop. And I'm going to shoot this with my Colt government model, which is loaded with Remington Green and White Box 45 ACP 230 grain jacketed hollow point. But I'm going to shoot it from a distance of 25 yards. Let's see what kind of effect we get. Well, I've got the meat target taken apart, and the ribs on the front of the target just have 45 caliber holes in them. Our orange lung tissue has some pretty good damage. The ribs on the back of the target just has 45 caliber holes through them. And our projectiles were all stopped anywhere from the 3rd layer to about the 14th layer of fleece. But let's take a close-up look at these projectiles. Here's our 5 projectiles. One of them has good expansion. As far as the other 4, the expansion ranges anywhere from non-existent all the way up to almost non-existent. That was very poor hollow point expansion. Now I have a new meat target set up, and we'll repeat this drill again with the Colt government model, still loaded with the Remington Green and White Box 230 grain jacketed hollow point, but now I'll shoot from a distance of 5 yards, and let's see what happens. Now give me a moment to take this apart and let's see what our hollow points look like. Well, I took the meat target apart and the damage is basically identical. But let's take a close-up look at these hollow point bullets that were fired from only 5 yards. And here's our projectiles that were fired from only 5 yards, and our expansion is anywhere from minimal down to none. Okay, now I have to take a moment and explain a little bit about behind the scenes and the planning process of doing demonstrations like this. When I do demonstrations like this, the great majority of the time, the results I get are exactly what I expected to get. Now today, what I expected to do was shoot a meat target from 25 yards with the Colt government model with the 230 grain jacketed hollow points and get very little to no expansion. And that's what happened. But then I'm going to shoot a meat target from 5 yards with the same gun and ammunition, and I expected to get pretty good expansion, and then I'd stand here and give you a speech about why that occurred. And so then we'd put in a new meat target, go back 25 yards, shoot it with the Kimber with the extra inch of barrel, 25 feet per second more velocity, and see if then at 25 yards we could get expansion, and so see if the Kimber would make the difference. Okay, the problem is that with the Colt government model and the 230 grain hollow points, I didn't get expansion at 5 yards. Why? There could be several reasons. It could be that those hollow points are getting clogged with cloth. It could be because these are extremely poorly designed bullets. Or it could be because those bullets are coming out of the muzzle already below expansion threshold. Now, let me give my speech about expansion threshold, and if you've heard it before, bear with me. Hollow points are velocity-based. The faster you propel them, the more expansion you'll get, up to a point. If you propel a hollow point too slowly, it'll drop below expansion threshold, and you'll get very little to no expansion. So is that what is happening here? Okay, well, we'll still go to our question of, will the Kimber with its extra inch of barrel and its 25 feet per second greater velocity make the difference? So we've got a new meat target set up, and I've got my Kimber loaded with the same Remington Green and White Box 45 ACP 230 grain jacketed hollow point, and I'll shoot this from 5 yards, and let's see if that extra 25 feet per second can get us above expansion threshold, provided that that was our problem. Now let's see how we did. In shooting this drill, the meat target fell over. I fired a couple more shots and they ended up missing the fleece bullet stop, so I lost those projectiles. So off camera, I set it up, redid it, and I ended up shooting more than 5 projectiles. Let me show you a close-up of the projectiles I recovered. I have 7 projectiles here. Remember, I fired more off camera. And we see that 2 have really no expansion, but the other 5 have very good expansion. So remember, our 2 questions today were, 1, will the extra barrel length in the Kimber give you more velocity than you got with the Colt government model? And if it does give you more, how much? And the answer is, yes, it did give us more velocity, about 25 feet per second more. Our second question was, is that going to be enough more to make a difference? And even more so, is it enough more to make the difference? And what we're able to show is that with the Colt government model, with the 230 grain bullets I was using today, at 5 yards, we got basically no expansion. But with the Kimber and its extra 25 feet per second of velocity, we got pretty good expansion. Not perfect. Of our 7 recovered projectiles, 2 had virtually no expansion, but 5 had very good expansion. So it would appear that extra 25 feet per second did get us just above expansion threshold. So I'm going to say, was it enough difference to make the difference? Yes. Now this is going to generate some questions about 185 grain projectiles. To the best of my recollection, using the Colt government model, every 45 ACP 185 grain hollow point that I've ever fired has delivered good expansion. So if you got greater velocity out of the Kimber, would it really make a significant difference? I'm going to say probably not. But the next question we're going to have is about drop when shooting at long distance. Now, if you shoot your 230 grain projectiles at 100 yards, you're going to expect to get quite a bit of drop. Would the extra 25 feet per second that I got out of the Kimber significantly reduce that? I'm going to say not to a point that most of us would ever even notice. The amount it reduces your drop is going to be minimal. But again, that brings up the question about 185 grain projectiles. They're already going to have a significantly higher velocity. At 100, you're going to expect them not to drop like the 230s, but still to drop. Would you get enough more velocity out of the Kimber to now notice a significant reduction in that drop? And those will be good questions to ask in part 2 of today's presentation. So until then, don't try this at home on what you call a professional, and thanks for watching the Extra Inch of Barrel video.